Okay, Assalamualaikum and a very good morning. Thank you all for joining in. I'm not able to see the screen, but Anissa over here will be assisting me in case there's any questions whatsoever that you have. We do have signed up for about 78 people for this talk, but people are trickling in. I can understand that sometimes assessing the Microsoft Teams can be a challenge. So if, say, for example, all of you have some issues with it, do feedback us. Probably next time we can make use of probably using the Zoom or some sort like that. Yeah. Okay. The talk that you all will be listening today will be applications of machine learning in drilling real-time operations analysis. What is this all about? So let's talk about it in during this talk. We have 2 hour session where we will do a bit of a talk and then followed by the Q&A if you have any question, whatnot. Yeah. A little bit of background, yeah, to the session that we have today. We will be talking a little bit about introduction of the topic, and also about machine learning techniques in drilling operations. Then we will go into the real-time data analysis. Then we will take a look at the benefits and challenges in implementing this real-time data analysis, as well as some of the conclusions that we will have using this. A little bit of introduction to what Faazmiar is all about. You can actually find this information in our website, and there are 3 things that we are very much passionate about. One is bringing values to our clients. Secondly, is sharing our knowledge to the industry, as well as making Malaysia technology developing country as instead of just a user. Although right now, the main thing that Faazmiar Technology do is bringing in technology from Norway, from the UK, from the Europe, Austria, whatnot, all these applications, and we put together these applications for our client for their use. So what Faazmiar is trying to do as well is to develop our own technology. We deal a lot with software applications, things that you see on the web whatsoever. Those actually can be something that Faazmiar is actually providing. Yeah. All right. A little bit of the Faazmiar background. We do provide services in terms of the AI, machine learning. We take a look at the upstream oil and gas industry and help them. So that's the reason why our targeted audience for today's talk is are the university students who are actually learning petroleum engineering, oil and gas engineering, or any kind of engineering, mechanical, electrical, but they are very much interested to join in the oil and gas industry upstream, so that we can actually help them out to get them prepared for the industry. All of the talks that we have for in this series are actually skewed to that purpose, which is covering things that that is not being covered in your syllabus in the universities. Yeah. So if you see the poster that we have over here, all the 6 talks in this series of Unitech talk that Faazmiar Technology is doing for the university student, we are focusing more on technology use. Yeah. Meaning that the applications that is being used on the iClouds, using machine learning and artificial intelligence to make you all realize that that is the way to go in the future. In the universities currently, what you are learning is a lot more on the core subject of what petroleum engineering is all about, or oil and gas engineering is all about, because those are the core skill that you must have. But the technology part of it is something that is so important for you to understand that what the industry really wants right now. So in order to make yourself more valuable in the industry, it is good for you to have or actually to research yourself or get yourself prepared with the industry technology knowledge. So Faazmiar effort is to ensure that all the Malaysian graduates are prepared for the latest technology, because we do realize that whenever that we have Malaysia's graduate that comes into in the industry, they are good at the university course subject. However, when it comes to the technology use, they are not that well prepared. So we do have to actually bring in from the technology side to actually to actually supplement the need for the industry. Yeah. And what we wanted to do is to more on the closing the gap between the industry and academics. Anita, can you check on some of the mic if it's on, because I'm hearing a bit of see if there's someone actually mic is on. So if you just join in, please do check your mic whether it is on or not, so that we will not interrupt the rest from listening. This session is also recorded so that we can share it on the our YouTube channel, so that all of us can actually learn together. Yeah. At the end of the sessions, I would like all of you to ask the questions. Maybe we don't have the answer to your question, but we will try to help you out to find the answer to the question. Many of the questions that people actually have is not readily available. It's not something that you can find in the textbook, because the issues of technology in the oil and gas industry is developing every single day. Yeah. So we want to start this discussion of technology with all of the people who will be coming into the industry. That's the reason why we create this Unitech talk for all of you. So thank you for joining in, and please do sign up. And if you have the QR code, pass over to your friends, because we do want people to join in this talk. Yeah. So in this particular series of talk, we will have stick talks. Today is the very first session. The topic that we'll be covering today, which is on the machine learning in the real-time operations, is something that I have actually presented over to the UITM students, and they found this very, very helpful in for them to understand what is the requirement of the industry. And that's the reason why we got the idea to actually share it more with the rest of other university students. So we open this to all of the university students, especially those taking petroleum engineering. There are 6 universities in Malaysia having petroleum engineering. You have UTP, UTM, we have Curtin, Harriet Watts, UCSI, APU, and also oil and gas engineering from UITM. Yeah. So all of you should be joining us in this discussion, so that all of us can understand and make you actually prepared. Because whenever that you have listened to the talk that we have in this series, then it keeps your mind wonder, oh, I probably will need to know about this. All you have to do is just Google or chat GPT any of these topics, and you can get actually quite a good output. And what we'll be sharing as well, some of the papers that we, the speakers, are presenting. I have presented before, and something that we would like to share with all of you as well. You have three speakers for this particular series of six talks. There will be more speakers coming in the next series. So you will have me for today, and then followed by Tengku Azharuddin, a brilliant guy in digitalization, digitalization. He's the head of digital drilling operations. He's more hands-on into setting up the system as well as putting together the system for the client, advising them what exactly is necessary for this particular operation. As you know, drilling operations is very unique from one conditions to the other. Every single field, every single well poses different kind of challenges. And what Tengku Azharuddin does is actually advise them and also put together the system that will be benefit uh, our client. Yeah. So you will be listening to him on 29th of October. Then we also have Latif Desa, a very senior guy, yeah, and he has been a drilling manager before, and he has been a trainer before, and he's actually the head of training for Faazmiar, and he'll be talking more about uh, a very advanced topic, carbon capture, utilization, and storage. I hope all of you have this discussed in your universities, because CTU or CTUS is a topic that is really important out there. Of course, I will be coming back to you on the 25th of November. I will be presenting a paper that will be presented later this week over at the CAFIO, or the Conference for ASEAN Federation of Engineering Organizations, about cultural and organization barriers in well digitalization implementation. It is a very interesting topic, a topic that is dear to me, because whenever that we want to implement well digitalization, yeah, we know what issues we could be having in an organization. In a large organization or in a small organization, we basically will have some barriers. And that barriers is because of the cultural as well as organizational barriers. So if you would like to know more about that, do sign up for the session. Yeah. And so that we can discuss it together, because in this, as I mentioned, this is a new topic which is being discussed in the industry, and something for you to actually contribute as well to the industry. Please, you are a university student right now, um, and you are about to come out into the industry, and we would like to hear what you have to say as well, and probably you can bring in new ideas into this new topic. So, because you all are studying, and you do have research that you will be doing. This is a topic that all of you should be going into as well. Of course, later after that, Tengku will be coming back in on the 11th of December. and also talking more about the digital standing instruction, DSI. And this is another very, very interesting topic on how basically um, drilling instruction can be done using machine learning. So these are the topics that is really, really important for you to know. And right now, in this particular series, we focus a lot more on drilling. But in the next series, we will go a little bit into the GNG, more into the production side, more into the reservoir side, as well as the supply chain. And if you don't realize, in the whole perspective of field development plan, one of those um course that you will be taking in your fourth year, third or fourth year, field development, you have to understand the entire upstream as well as downstream of the petroleum industry. And this is where the topics can be discussed. Yeah. So Unitech Talk, Faazmiar Technology, Unitech Talk will try to discuss all of this information. Yeah. If you have questions right now, please do write it on the chat box. Later, Hanisa can help us to actually bring in this question so that we can discuss together. It does not mean that I can answer. I probably cannot answer. I am not the expert in this area, but I am in this area of the industry where we want to talk about the technology, latest technology going out. Yeah. So a little bit about myself. I do have more than 20 years of experience in the oil and gas industry. Usually, when people have actually, um, are quite old, they do not want to say the exact number of years that we are actually in, so that people don't really able to calculate how old you actually are. But yeah, I've been in the industry for quite some time. My I was a petroleum engineering student from Colorado School of Mines, and I do have an MBA as well. So I started my career in as a drilling engineer. So a lot of my work are actually in drilling. I have worked in many companies, and mostly is these companies are as independent consultant, because after about 10 years of working, I go out on my own and open up my own company, and then realize that I have a little bit more flexibility in my life when I become a consultant, and that's what I do. I also involve a lot with the Institution of Engineers Malaysia. I hope you all students over there are actually a member of IEM. If you have not, please do sign up. Yeah. And I hope all of you realize as well, you all are engineers, and what you will need to do upon graduation, you would want to actually register yourself with the Board of Engineers Malaysia. Yeah, so make sure you do that. So my specialty is the well engineering, operations and project management, as well as drilling data management and drilling applications. If you realize, when I was over in Landmark Graphics, probably you have been using software from Landmark Graphics or Halliburton, where you will be looking at applications like Compass, Well Plan, Open Wells, Wellcat, and so on and so forth. So those are the drilling applications that I was using before, that I was the trainer before, and those that I sold. So I am a professional engineer with practicing certificate. So if you have any more questions about those areas, we can talk separately. But for today, I would like to focus a lot more on what the technology is all about. Yeah, about the use of machine learning. Yeah. So let's just dig into the machine learning and the oil and gas industry. So you when we talk about uh, artificial intelligence, yeah, when we talk about artificial intelligence, what it is actually we want to make the computers learn and make predictions or decision based on data, meaning that it is actually trying to bring me people with certain number of experience into the computer and to make me a a more efficient thinker. So if I if I were to see an operation, yeah, if I were to see an operations, I would say, okay, next thing you should be doing this is that is because in my mind I have already calculated. Okay, based on my previous experience, I have seen these issues before. This is how I deal with it. So, but the logic thinking that I have, I will put it inside the computer. So that's the reason why it is called artificial intelligence. Yeah. So how do you want to differentiate that? So traditional programming, I hope all of you actually learn traditional programming now. Last time I had like Fortran, um, C language, and so on and so forth. And I hope right now all of you at least learn about Python and so on and so forth. Because this traditional programming, what it does is it it gives it follows an explicit instruction, meaning that if I tell the computer, if you see a rate of penetration is increasing, then shut down the operation. So that's what the computer will actually do when the ROP increase tremendously, and I define what tremendous means, 10%, 20%, 30%, and so on and so forth, and it will stop. That's about it. Then the next level of machine learning is where I will put in an algorithm. Algorithm will be an instruction with options as well as asking them to research a certain amount of data. So improve performance with more data. Therefore, say for example, if the ROP increases tremendously or 10%, 20%, I will have to define that. Or they will search for what is the percentage that will lead to problems and bring that idea of that percentage and problems into the algorithm and ask the computer to actually analyze those instructions. So what is it? Then it will search for what kind of formation that I am drilling right now. How is that formation compared to the offset wells that I have drilled before? Realize it is trying to become me. It is trying to become me because that's exactly what I would be doing. I will be looking for information from the previous data. I will be comparing those information, and then I will make a recommendation. And from that recommendation is where that machine learning is all about. So realize over here, it is an artificial intelligence. The intelligence is still the human. The information still come from the people who have worked in the industry. We are trying because I will not be around for a very much long time, because I'm already old. But the younger generation will need to actually take whatever experience that I have before, whatever logic that I have before, and put it inside the computer so that the computer can keep on making it better and better. How? Because the more information that you have, the more ability of the computer to make that comparison and make better recommendation. That's all that it actually does. Because last time, when I was working as a drilling engineer, whenever that I see some problems coming, or whenever that I'm analyzing a certain issue, I would need to go to the library and look at like probably like 50, 60 number of wells and flipping through like thick files, going through, the formation information, the notice of operation, the daily drilling report, and so on and so forth. In order for me to summarize those information, which may takes like hours, sometimes days, sometimes weeks, in order to come to the recommendation, which the machine learning or the computer is able to do that within seconds. That's how powerful it is. And one thing that probably this sounds, if you have not indulged yourself in the AI and also machine learning, probably what I'm telling you right now seems scary to you. However, let me tell you, AI and machine learning is the way to go in the future. It does not replaces human. It does not replaces me. It does not replaces you, but it elevates you to the next level as a human, because your work is no longer running to the library searching for information for hours, days, or weeks, but you basically make that decision based on the information that the machine learning has provided you. And then you make that decision what exactly you want to do in the operation. Very interesting, isn't it? So let's go on a little bit more detail in understanding what machine learning and oil and gas is all about. So primary types of machine learning. So we take a look at three types over here: supervised learning, unsupervised learning, as well as reinforced learning. So the first is the supervised learning. What exactly is supervised learning? Because in supervised learning, what you do is you give data a label. So one data, one label. So what happens to that particular label? You just call out that label. So ROP. So ROP on past data, meaning that ROP that was done before in the offset wells. Remember, always remember, the more data that you have, the better decision that you're making. Actually, I could have said the more information that I have, the better decision that I will be making. And that's the same thing that machine learning will say as well. The more data that it has, but the better recommendation that it can actually generate to you. So supervised learning is you just put the label on the data and you call out that particular data. Unsupervised learning is, on the other hand, is making an algorithm which find patterns on unlabeled data, meaning that you don't label that data, but you take a look at the trends. If all of you are in the third year or the fourth year of your course in petroleum engineering or oil and gas industry, or if you are into the specialty of petroleum engineering or oil and gas, you will actually realize that all that we do, yeah, is looking at trends. Because until now, I have not actually sent anyone down the hole to check for me what exactly is happening 3 kilometers down, into the formation, because you can't even go there. But I sent in the the tools inside that sensors, so that the sensors can give me information, and this information comes in the form of trends. Ah, so that's why learning algorithm, which finds a trend in the data that we provided. So we can cluster similar events. So if I am seeing that I have lost circulation, what does it mean, lost circulation? I hope you know, yeah, because if you are in the third or fourth year, you have taken um, the drilling subject, and that basically is an important part of your course. And if you are not doing drilling, yeah, in the future, there will be courses, there will be talks that we will be doing, which focuses on GNG, geology and geophysics, because that is part of the petroleum engineering. We will be talking as well about the supply chain as well as production and so on and so forth. So do sign up for our future series of talks. Yeah. Okay. And the third kind of learning, machine learning, is actually reinforcement learning. So what exactly is reinforcement learning? This is where you will get the algorithm. It gets complex. This is the part where the algorithm will get complex, because it will have to interact with the environment, and it will have to receive feedback and analyze it. And this is how optimizing a drilling path real time is really, really crucial. Yeah. So reinforcement learning is where you will get the machine learning to learn from the environment, to learn from your sensors that you have out there. So very interesting how we want to make a machine to learn, to basically become you, yeah, in the future. Not to replace you, but to make sure that you will do a better work of recommending what will be the best options in the future. Yeah. Machine learning in oil and gas is so important because oil and gas industry, yeah, especially in the upstream or even downstream as well. So in the upstream, from geology and geophysics, yeah, those amount of information are tremendous, because we do have seismic information inside there, all the tops information, the formation content information and characteristic and so on and so forth. Vast amount of data. And if I were to go, or even in my team, in FDP team, the geologists and also geophysicists, whenever that they they take months to actually learn those information, yeah, to basically understand what is going on, because it is not just about getting those information, look at it and then you understand. No, because you have to look at so many, and then you have to correct it, because data will need to be cleaned up before you are before we are able to actually understand it, because it comes in the form of colors, it comes in the form of squiggle lines, it comes in the form of numbers that you can't even understand if you give to the normal people who has not gone through any of the trainings that we uh, or you are having right now, or I had. Then they can't even comprehend what exactly those information is all about. Yeah. So analyze the data in real time. So before this, yeah, when I started off with landmark graphics, we do have all this information as well, but those are not real time, because it takes time for the computer to process those information. Those were like 20 years ago. and 20 years ago, the technology wasn't there. The speed of computer thinking wasn't there yet. So it does take time for those information to generate information. So, for example, if you run previously, if you have like run those reservoir information, 2 hours after that, only then you can get some information. And that is when you even put a smaller amount of data. So realize now we have a lot more data. There's a lot more data available for us to actually make comparisons to, as well as learning from. So that's that's why we need speed. That's why we need power in our machines. Yeah. So it provides us the options that we have, providing us insights which previously is not available. So these are really, really important for us to have. And also, what it does is transform drilling operations, making it more efficient, safe, and cost effective. These three items, yeah. If you take a look at this chart over here, you have machine learning, which promotes safe, safety, efficiency, as well as cost efficiency. Yeah, all these three things lead to the to operations that is more conducive, more systematic in our operations. Yeah. So machine learning about data collection and processing. Just now I mentioned over to you, data is totally useless if they are not the right data, they are not the data that makes sense. So what do I mean by data that makes sense? Data, data, if you see, computer understand one and zeros. And from that one and zeros, it will translate into numbers. And from that numbers, it translate into line. And from that line, it translate into me understanding as trend. Yeah. So all of this process is being done by the computer. But in order for me to make sure that the computer understand the data, it needs to be cleaned up first. It needs to know where the sources of this information comes in. Because if I know what kind of information I'll be looking at, is it from MDT? Is it from LWD? Is it from MWD? Is it from any other news sensors? Because right now we have so many new sensors that comes out. Probably it's time for me to actually talk about one of the latest things that Faazmiar technology is doing is bringing Malaysians ideas of coming up with new kind of sensors to develop it and to commercialize it. So all of you, if any of you have any ideas about new technology that you would like to commercialize it and you don't know how to do it, Faazmiar technology can actually help you because as I mentioned earlier, one of the things that Faazmiar Technology wants to do is to help Malaysia to become a technology developer instead of just technology user that we are now. Yeah. So sensors on drilling equipment are really important. What kind of sensors are those? And then what kind of data that you generate from these sensors? And then you do have the operational logs. So logs that you see, squiggle lines. Again, squiggle lines. Previously, when this comes into the office by fax, what I need to do is to understand these lines and then retrace it. Or at some point later in my life, I actually have to digitize it. yeah, digitize these logs, because from the trends, I would need to convert it into the scales that we have now, so that the computer would understand. The computer would not understand if I just simply put in a screen capture, but now probably it does, because the computer has more capability to actually analyze things. So that is what is interesting. I am excited about the new technology, and I hope all of you will join in the bandwagon together we develop this technology, because this is the way to go in the future. It makes the operation much safer. It makes the operations more cost efficient, as well as more effective. Yeah. So environmental measurements are where we also take a look at what's going on outside, in the environment, and we take that measurement. So all of these data collected, it comes from different sources, and from these sources is where those information are being analyzed. So, and I remember, I kept on saying, it's probably the third time I mentioned it, data must be clean and pre-processed to ensure its quality and reliability. Yeah. So when we talk about clean, what exactly does cleaning or data cleaning means? Okay. Previously, when I was with Landmark Graphics, we were in an organization which wanted to do well digitalization. This is the way back, like probably 20 years, probably 15 to 18 years ago. Yeah. So we have data for about 40 years of drilling data. But the work is, how do we want to bring that data into the computer so that computer can analyze it? So we input the data. After you input the data, when we bring in people to input the data, we bring in human, and human makes mistakes. So that's the reason why data will need to be adjusted, will need to be clean. For example, normalization. Yeah, normalization is whenever that, say for example, right now I think you are doing as well for your FDP, where you will take a look at the logs, and then you would try to bring the depth together, so that you are looking at the correct depth. Yeah, that is one of the example. And outliers detection. This is where computer does it really well, faster than human. Well, human can do it as well. Is whenever that you have a group of data, and then it puts together those information, and uh, it will detect, oh, this information is wrong. This information is wrong. This information is wrong. So what do we do with it? Do we just take it out? Do we take out all those information, and suddenly, the data becomes so chanty? Is that what we want? So we, the human, will need to clean up and make that decision whether that particular data actually belongs there or not. How do we want to know that? Because we understand, the data next to it. All that is all that we can do. As I mentioned, remember just now, I have never sent anyone down the hole yet to actually take a look what exactly is happening there. So what we can actually do is, you know analyze those information of whatever that we have in hand. Feature extraction is also very important. It's where we want to take out some of parts of the data, so that the computer can actually understand what exactly that it has to analyze. Where's the header? What exactly do I want to actually, what exactly do um, do people like me want the computer to do? Because the computer needs to understand all of that. Yeah. So that is data collection and pre-processing. Yeah. So I wouldn't want to go into details in this, but just to let you know, the key algorithms and also the models that we need to use, say, for example, regression models, because it predicts anything that does not fall in line, and it basically take a look at trend and say, for example, if the casting has worn out, then it will be able to actually know how basically it would know because it plots, because it search out, if an equipment, how long has the equipment been used? So they search for that data. What, when was the equipment used before? When was it manufactured? How many times has it been used? And then in the last usage, how much wear was that? And based on the strength of the material that we use, how much wear can we expect? What kind of forces or friction that the equipment has gone through? So many questions, isn't it? Don't worry, because computer can actually handle that. But you will need to do the thinking, because I can do so much. But the new generations, when they take over, they will have a lot more ideas and a lot more things that they want the computer to do them for them. Yeah. So that's why together we will need to make sure that we develop the new technology for Malaysia. Yeah. I hope all of you are with me in this. Yeah. Okay. So classification models is where we use the support factor machines to classify the operational state and detect anomalies. Okay. These are different models that we use for different kind of usage for computer to understand it. Yeah, clustering models. So we have k-means clustering. So what it does is identifies the pattern in drilling data, such as grouping similar operational events. So if you are seeing all of this, whole problem, so in the whole problem, what kind of whole problem are we looking at? Is it the whole problem because the cuttings caved in? Is it because the cuttings basically just lying over there? Those information will need to go together. What kind of wells are we drilling? Wow, there's so many things going on over there, isn't it? So I know when I basically have to do the work myself, um, I was like, I have to take a look, put everything together, and I have like a big table in front of me with full of graphs so that I can, do that together. But for now, I can get the computer to look at all of that. So how neat is that? Yeah. Networks as well as deep learning. Okay, this one is a powerful for complex pattern recognition. Basically, it takes a look at any correlation when you have a large data set. Again, the technology that we use over here, it basically deals with IoT, it deals with big data, and so on and so forth. The more, the longer that we go, the bigger data that we will have. Currently, I don't think we have information way past like probably 50 years ago. We don't have information with that. And I don't think at that time as well, we it is and information that I want to digitalize, because I don't think those information would be helpful for me. Especially those wells that was drilled in the 60s, 70s, because they were using different kind of technology during that time. So, but I probably would need to take a look at some, because probably the last time I have actually drilled in a particular area was in the 60s. So I will definitely need to take a look at the information from the 60s, because that is the only information that is available for that particular area. But of course, I would have to couple it together with the latest technology used, so that all this information are available for the machine learning to do the thinking for us. Yeah. All right. So real-time data. So when we talk about real-time data analysis over here, yeah, we talk about what happens like 3 seconds, or 5 seconds, or 7 seconds offshore, and we get to see what exactly is going on here real time. Yeah. So how does real time operations work? Yeah. So what we do is, whenever that our clients wants to have a real time operations, then we will put together applications that comes from different providers. Each one will have its own uh, functions in that real-time center. So it basically starts off with having you know if there is an alert triggered here. When we say alert triggered, is it means that the sensor put have issues in terms of like putting together like warning sign. Yeah. So what we will do is we will zoom in and evaluate the alert, and then we have to cross-check that with the surveillance tool. When we talk about static and dynamic, static basically is the capture of information during that particular time, and dynamic basically looks at information that is still moving on. Yeah. So we zoom in that and evaluate this warning, and then we validate that sensor reading with the rig side. Yeah, because we have to make sure whatever that we are seeing over in the real time center is something that also be seen in the rig side, and then we have to communicate that particular alert to the authorized personnel at rig site. Yeah, this is where the communication comes in, and then we will say, "Oh, we are detecting this. Is it true? Whatever that is going on over there? Okay." And what we will do as well, we will say, okay, the computer says that you probably have some issues of hole cleaning. It is good for you to have to actually clean up, probably stop the drilling right now, and then clean up the hole so that your hole is cleaner. So that is our recommendation. And then of course, we need to log and also distribute that particular intervention so that everyone knows, that, we are encountering problems, and this is what we will do. Whatever the recommendation that is put together by the computer, it doesn't mean that it's right. Can I trust it 100%? Even I am in the technology industry, I don't put 100% trust in the technology. Of course, I would like to actually review what kind of recommendation that it provides, and whether it goes along the line of my experience. You see over there how important having human in the process of this real-time operations, because nothing actually replaces us human in terms of our ability to analyze, and also we feel. Yeah, sometimes I would not, put a judgment or a recommendation based on my feel. However, my feel would result in me going back and relook at certain data, whether that data is right or not, and whether that data is valid to be analyzed together or not. So this is the part where computer can never replace us. Yeah. So that is where the real-time visualization platform comes in. It goes in the loop, and every time that we put together, uh, this particular package, it basically helps out our client to make better decision for the operations. Remember, the technology that we have over here is number one for the safety. We do not want any mishaps to happen, blow out or whatnot. We do not want that. So we use technology for safety. Of course, operations efficiency. Yeah. Because everything that we do on board of drilling operations, it costs money. And of course, the third is for us to actually have uh, better cost efficiency. Yeah. So, what contains in that real-time monitoring system? Number one is integrate machine learning models to analyze the data as it is collected. So you realize all this information from the sensors that we have, from the tools that we have, and from the things that we are seeing at the uh, rig side. Those are integrated um, as part of the machine learning models. It basically consists of sensors, data processing unit, as well as interfaces for operators. So sensors is we put on the tool. It basically brings in information real time. Yeah. Previously, probably those information are kept until you pull out the tool, but nowadays, all of the information from sensors are being sent, uh, you know, uh, real time. Of course, data processing unit. Data processing unit is where you will bring in all of this information. It will put together in a table that is understandable, a chart which shows trends, and explain to you why basically things are that way. And of course, interfaces with the operators where those information is presented in a form which is understandable. Probably it's in the form of blink of light saying that slow down ROP. So it keeps on flashing that lights slow down ROP because it needs to interface with a human. Again, it basically will make the operations safer, and it doesn't replace us human beings. It basically elevates us to the next level. Of course, provide immediate feedback and insight because you know, with the new information that comes in, it will continue on to put together all this information and analyze it together with the rest of other information that is already there. Yeah. So with this information, it will generate over to you a lot more better recommendation. Yeah. So applications in real-time operation, one of the biggest things that it is information important is the collaboration platform, yeah, because it enable the real-time data management. It basically to enable effective data sharing and visualization. So when we put everything together, yeah, number one is the historical data management. How basically this historical data is managed. Of course, things that we do here is because all of the information, oil and gas information, are actually very confidential. It's proprietary to the owner of the asset. Yeah. So, and you do, I hope all of you realize how valuable those information are, because those information can cost millions and millions, and people would want to actually have that. So that's why cybersecurity is really important. Data acquisition is where you want to actually get the information from. Sometimes you can buy it. Sometimes you would want to actually get those information from downhole yourselves. That's the reason why you want to drill the exploration wells or appraisal wells. Yeah, and how that data is transmitted over to us, and how that data transmitted is actually integrated into the available data, and then it is presented in the visualization platform that you can understand, and you're able to do real-time analysis. Well, actually, most of the analysis is done by the computer and it presents over to you. But I can assure you, your understanding is so important, because in order for you to understand what those lines and colors and numbers actually mean, you will need to understand the entire operation. So don't boil down saying that, "Ooh, with the technology, with the machine learning, we don't need drilling engineers anymore." No, their work is still there, and it basically will also create work for other people, probably technologies or technicians who runs the application, who who basically puts together these applications together, who inputs in the data, and who basically present this data in a very understandable way, so that drilling engineer can continue to analyze. Realize over here, how the team has to work together to make sure that the operations can stay safe, efficient, as well as cost effective. Yeah. So in the JASTIC real-time data protocol, when we have information comes in all kinds of form. And the information that comes previously, if you go all the way back into how machine actually understand us, is one and zeros. Those are the only two numbers. Binary system. Yeah. So binary system, one and zeros. That's all that it can actually understand us. So we have developed from there, from the one zeros into now ability to actually understand, pictures. How exactly do computers actually understand pictures? We teach them with one and zeros. Yeah. So realize over there, we have come so far in developing this new technology, and it's going to be better and better each day. Yeah. So Energetic Real-Time Data Protocol is a provider that has put together information, like, for example, the well site information, reservoir models, as well as production models together in a kind of like a data protocol where we can exchange data much easier, really neat. Yeah. Applications in the real-time operations, these are the data standards that we use. You don't have to know this, but know its existence, because some along the way you probably will be hearing what JSON is. JSON is not your friend or my friend. It's basically a JavaScript object notation. Yeah. So please know what this is all about. You don't have to be an expert in this area. Um, we do have developer to understand this and to help us with this. And if you are in engineering or technology, or even if you are in doing a diploma in engineering, all of this is something that you probably would want to understand a little bit. Yeah. Of course, we have computer science uh, friends that will help us with all of this. Yeah. But that does not mean that you don't need to know, because from my experience, it's always good to know everything that works around you, because you can help them to understand you. Because most of the time people don't understand each other because we are too bogged down in our expertise. Yeah, so we know about our part only. Say for example, I've been in drilling for more than 20 years, you know and I basically know everything about drilling, but do I know about the technology in drilling? I probably don't. Had I not come into Faazmiar technology, had I not been in landmark graphics, I probably am still, don't understand what all of this can actually provide me. But that's the reason why I stand here today, sharing with you whatever that I know about the new technology, so that all of you can actually learn together with me. Yeah? All right. So applications in real-time operations, again about the collaboration platform. It is an operation surveillance and support, because during the drilling and well operations, it basically put together a storyline of what is going on, and so on and so forth. For example, over here, yeah, um, when we have the well data management, it goes into the operation surveillance, where we monitor the well, and then we enhance operation safety, and then we enhance the operations efficiency, and then we have the data analysis and for us to actually take a look, so that we can provide decision support. Yeah, and this is done real time. So when we talk about real time, whatever that is going on right now, so it'll be probably in the next talk, you we can discuss a little bit more with Tengku Azharuddin, who basically will be doing more about this topic, but go a little bit deeper. Yeah, a bit deeper. That's the reason why I'm doing this talk today, so that it gives you the idea of what real-time operations, machine learning is all about. But we will be talking more about this in the next talk. So if you have not signed up for the next talk, please do sign up. And if you have friends who are interested to join in as well, please do let them come in. Yeah. And of course, applications in real-time operations, we take a look at it is important because of this predictive maintenance, anomaly detection, drilling optimization, of course, safety monitoring. Predictive maintenance is where we talked a little bit earlier about equipment wear, yeah, wear and tear, because the machine learning can predict equipment failures before they happen, because you know the machines, the computer would know, what kind of material that is, how long does it last, what kind of how long has it been used, and then what kind of environment it was being used before, and at the last usage, what was the condition, and it can calculate for you how long it can actually last. Yeah. So all of this information is very important in our preventive maintenance. Of course, next is anomaly detection, because information are never, data that you receive is never perfect. Information comes in many forms. Information sometimes are put together wrongly. Information sometimes are transferred wrongly. Information sometimes are not collected properly. And this is where your equipment are not being cleaned properly, or if your equipment are not calibrated. So there's a lot of reason for information to be corrupted. And so many people will tell you data, data in, bad data out. So it is important for us to understand anomaly. And sometimes anomaly is a real issue. Is there things like pressure changes? It can be detected quite immediately. Sorry, let me just have a sip of water. So anomaly detection is really, really important. Yeah. So the next one is drilling optimization, because it will advise you what kind of parameters that you should be doing the drilling, uh, the speed, the rate of penetration, what kind of pressure are you expecting, what kind of torque are you expecting in this particular um, part, and then in this particular part of the hole, and what kind of all of this can be optimized by machine learning. So, and in real time. And safety monitoring is also very important. That is to make sure that we can predict any kind of potential hazard. Nowadays, even you have cameras that can actually detect human beings, whether they are wearing uh, helmet, whether they are wearing proper shoes, and so on and so forth. So technology has developed quite um, far, where you can actually do a lot more with this information. So some of the examples that you will be seeing, yeah, if you work in drilling, or if you work as a petroleum engineer, or as a drilling engineer, reservoir engineer, production engineer, or even economics, petroleum economics engineer, all of this information is so important over to you, and you may need to come across some of this information, because this information will actually help you to understand what kind of problems that you are seeing. Yeah, because when you are in a team, yeah, it's not, this information is not just for drilling engineers or reservoir engineers. It basically important for the team. So advanced real-time operation data display, it gives you a lot of these colorful pictures, but you need to understand what these colorful pictures actually carries. For example, if you have information on the, if you need the information on the cement integrity, for example, after you have cemented, whether the cement has actually covered the hole, you can actually have that as part of this squiggle line. Are you drilling into sand? Are you drilling into shale? Are you drilling into silty sand? Are you drilling into, you know, carbonate? So you will be able to actually know that with the sensors that you have put down there. Or even sometimes in the parameters of drilling. Yeah. Say for example, you are drilling and then suddenly your bit just turns around really, really fast. That means your revolution is really, really fast. What exactly is that indication? Is it like, something, what is wrong over there? Probably you are drilling into coal, you know, because because of the layers of the surface that is, um, you know, that is uh, not rough, then it basically will let the bed to turn really, really fast. So those indication, those information will still need you as an engineer to figure out, and also it will actually help you to understand more of what is going on downhole. Important for you to understand what is going on downhole in order for you to make a good decision of what to do. Yeah. And also visualizing subsurface reefs from adjacent historical wells. So when you are able to put together all of this offset wells that are drilled from previously from around that location, then you will be able to understand. You are drilling into this particular depth, and I'm expecting that. But you do have to make sure that you have aligned it correctly. And I think this is the process that you do as well for your FDP. Yeah. And I hope that all of you have done it by hand so that you really understand what is going on. How basically this is done, because you can always do this using the computer nowadays, and it is much much easier. Even you can let the computer figure out whether it needs to juggle up much much faster. Amazing, isn't it? So operational annotation, command, and pre-drill identified risk, as well as you see over there. What kind of formation marker, and where is that formation marker? I'm not seeing that formation marker in this particular depth, and probably it's on a different depth. Why is it on a different depth? Because formations are not like straight lines, horizontal. It basically goes up and down and so on and so forth. Yeah. So visualizing subsurface risk from adjacent historical well. And of course, mobility is really important nowadays, because whenever that you put together um, a, a facility to help engineers or their managers understand what is going on offshore, because previously probably I will be calling offshore like every 2 hours, so that I would know what exactly is the update. But for now, all I have to do is just open up my mobile phone, and then I will just go into the applications and look at the charts as well as the numbers, and see what exactly is going on with the operations need, isn't it? So that's what technology gives us. It basically gives us that ability to, to monitor the operations. I can monitor it, not just over in KL, because previously, whenever that I am on weekend duty, I have to be within 10 kilometers away from the office, because if there were anything were to happen, everyone will need to gather. But nowadays, if something were to happen, we can have real-time operation center handle it, or if it becomes very, very crucial, then we all can actually gather on Zoom or Microsoft Teams or whatsoever. But if you have the older generation, they probably prefer to actually work together face to face. You still need to come to the office. Okay, all right. So another visualization that you get is, for example, the start pipe module. So before start pipe actually happens, we will need to be able to predict why basic is there any potential of it to happen? What is the telltale sign that stuck pipe will actually happen? Reduction in flow rate while drilling over certain interval. You have hydrocarbon agent flag warning due to possibilities of cuttings overloading. So where exactly it is happening, why basically it is happening, you know, all of that you can actually answer in this kind of applications. Yeah. And of course, ROP optimization module, because as you are drilling into a certain formation, the ROP switch differently. If you are in a different angle, the ROP will indicate wrong or differently. And if you are in a certain, condition, whatnot, it basically will give different kind of ROP, meaning that, it slows down after you have putting in as the same amount of force. So it is really important for us to maintain the ROP so that we understand what is going on downhole. So very important for us to understand what is going on downhole so that we can make better decision. What is basically better decision? Can we actually drill it faster? Am I going to get into problems if I were to go in faster? You know, all of those information will be made available to you. Yeah. So we come to the last topic of this, and I hope you give me a bit more time, and then we will start our discussion with the Q&A. And hold on as well, if you would like to have conversation after this. And also, Hanisa will provide information, um, my information in case you have more information. She will provide you with the email address so that you can type in with us or chat with us about some of the questions with regards to technology, because all we are doing over here is to make you aware how important technology is when you get into the industry. Okay? All right. So let's take a look at the advantages of machine learning in drilling. So the purpose, we have heard, objective, we already know, safety, operations efficiency, as well as the third one as the cost saving. But it is more than that, because one of the advantages of machine learning, it basically enhances the decision making. What do I mean by that? So if I were to get out and do the work of a drilling engineer, then I would be limited into the my experience, and also how much have I studied those wells from historically. However, with the machine learning, I can make use of Pak Tip's experience. I can make use of Tengku Azharuddin's experience. I can make use of other people's experience elsewhere into my decision making for my particular well. How great is that, isn't it? I mean, it makes my decision making much easier, because if I don't trust myself, I can at least trust my colleagues. Yeah, I can when with colleagues, when we have the same kind of ideas, then we decided that that is true, it is correct. So that's the whole idea of what machine learning actually provide you. Reduce downtime, because you have a preventive maintenance over there, because you basically allow, like, the computer to predict whether your tools can actually stand a little bit longer or not. And of course, improve safety, as what I mentioned earlier, because it basically stops the risk or stops the problems before it happens. For example, in relation to the enhanced or predictive maintenance over there, if I have done the maintenance properly, then I will not have two failure in the whole. But sometimes it still happen. But then it basically reduce the chances of equipment fail in the whole. Yeah, and it basically stops the issues of safety from happening. Of course, cost saving, that is where whenever that you increase efficiency and reduce the downtime, it basically will lead to the significant cost reduction. And of course, challenges and also these considerations that you probably want to have whenever that you get into the industry: data quality and also availability. This is where um, you have to make sure that the data quality is there, because high quality data is crucial for effective machine learning models, because information that is learned, which wrong information which is learned by the machine, it will be part of their decision making or recommendation making. So it is very important for us to actually make sure that we have everything considered. Yeah, integration with existing system, because integrating with existing system is very important, because it has to follow the workflow and system that is already at the client side. Yeah. So whenever that we put together a system, we have to actually learn what the client side have been doing, because whenever that the client it fits into the workflow, it basically will make the efficiency increase. And of course, the skill and expertise. Implementing that machine learning requires specialized skills in both data science as well as drilling operations. So when we talk about data science over here, we talk about geology information, and also your ability to code so that you can actually help the engineering side to understand, what exactly is the language behind a certain operations. Yeah. And of course, the ethical consideration and data privacy, where ensuring the data privacy as well as confidentiality is of concern during this particular uh, case. Yeah, always understand, even if your friends basically don't really care about the data, but you you should actually make sure that this data is well taken care of, meaning that it is always in the safe hands, because this information can cost millions. We come to the last part of our presentation over here, then we can actually have our discussion. So machine learning over here is about uh, it's a transformative potential, because it brings that real-time operations analysis in drilling into the next level. Yeah, probably previously, you are afraid to make use of whatever information that is churned out by the computer. But nowadays, the computer gives you options, can actually give you options so that you can choose what would be the best way to proceed with your operations. Machine learning is so important because this is where you want to make sure that uh, all the information that you have with regard to the well that you are drilling is inside so that it can actually understand. Yeah. Leveraging on advanced algorithm as well as real-time data, because this is the part where we want the latest algorithm. So some of our our principals, the people that we bring in from Norway, Austria, and so on and so forth, they keep on developing and keep on researching what will be the best algorithm, because uh, certain algorithm can be really, really good, but the way that it is written is such that it is not efficient. So whenever that you want to run as an application, it takes ages for it to actually do the work. Or whether we don't have enough capacity to actually, uh, come up with a good server. It could be hardware, it could be software, it could be outside element that basically will impact the entire use of technology over here. Yeah, enhance efficiency, safety, and decision making in drilling operations. That is the most important part. If I have not repeated like probably 10 times about the enhanced efficiency, um, safety, as well as decision making, then probably I'm not doing my job over here. And I hope those three items is something that you will actually put everything together. Yeah. So please, if you have any question, please do join in the conversation that we have. Probably I can ask Hanisa if we have any question. We'll start
Yeah.
share.
So, is there any questions from attendees here? Uh, Feel free to drop your questions in the chat box if you.
If you have if you need to you know send email over to me, you can always send email to the email that I provided over here, uh, and if you would like to ask any kind of questions whatsoever which I cannot answer, I can probably try to find those answers for you. Yeah. So please do communicate with us, and I hope you benefit from this talk that we have today, and continue to join in the talk that we have um, put together in the series. We have 6 talks in the series number one, and we will be bringing the series number two shortly as well, so that you all can plan properly, what you wanted, which topic that is dear to you. Yeah. Well, if you don't have further questions, I hope you enjoyed the talk. And please, I pass over to you, to Anissa, for the closing. Thank you. Anissa?
Alright. So before we wrap up our first session, we kindly request for all attendees to take a moment to complete the feedback form via the QR code that we shared. We because we need your feedback to help us enhance our future sessions. Thank you for your feedback.
I hope to see all of you in the next talk session that we will have. That will be on the 25th of October, or is it 29th of October? I forgot. So do join us in that topic as well. That will be more interesting. Yeah. All right. Thank you all for joining in, and I hope all of you benefit from the talk. Bye.